Okay, sekarang ni saya share screen. Tapi lah, maybe kalau you all rasa 3 minit tu singkat sangat, maybe kita buat 5 minit kot. Okay. 5 minit sounds okay? Sempat ke nak buat nak buat quadratic equation? Calculate standard error. Masa buat soalan tu memang masa tu saya bila gelak tu macam evil laughter. Ha 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 ha. Tapi itulah. Tak apa, kita nak semua belajar, okay? Alright. Dan insyaAllah yang CBE Khamis ni kita akan buat dry run. Okay. Next one is how to do chi-square on R. Again, Ayub just stated the usual facts. The only difference I think you notice number 4. Dia kata the smallest expected count must be at least 2. If you check the notes, they say, my note says it must be at least 1. I did check with SPSS, it is stated as the smallest count should be at least 1. So I don't know where he got the 2. Okay, so chi-square test, dia cerita what is the proportion of obesity between male and female? Is it the same or is it different? Okay, we have to calculate the expected count for each cells. Okay, so command dia untuk R, you kena install packages G models. Okay, you kena install packages G models. So you go, okay, so jangan risau, jangan ragu, select copy. So okay, silap. Sebelum apa-apa kena tengok dataset dulu. Okay. Okay, gender dan obesity. So which dataset? Dataset OS. So ini adalah dataset OS. So kita boleh run untuk guna dataset OS. So kita tahu kita ada dataset OS. Make sure kat atas belah kanan ni datasetnya adalah dataset OS. Okay. So dataset saya adalah dataset OS. Ianya ada semua termasuk gender, tapi gender dia adalah gender 2. Okay. So first kita akan install packages. Tekan enter. So dia akan start installing packages. So please take note, for computer based exam, make sure your internet is laju. Next, you have to trigger the library so that they will run. So the packages will only run if you trigger it. Ada 2 ways. Either you klik dekat sini. Okay. You klik kat sini, dia akan trigger. Nampak kat bawah tu ditulis library G models. Okay. Ataupun anda type sini perkataan library G models kat bawah. Next. Then you run the analysis. The command is cross table. Okay. So the command is cross tables. Siap boleh minta tu format SPSS. So copy. Pergi dekat R. Very sorry. Dr. Nasir, kadang bila dia doktor ni dia rasa dia betul dan dia nak cerita dia orang akan dengar. Okay, I'm very sorry about that. Okay, let's go back. Okay, so we are here on this command. Okay. Sorry, command tak keluar kat bawah tu. Boleh nampak Hihi, tak boleh nampak. Sekejap deg deg deg. Okay, ni boleh kecil. Saya akan tarik ke bawah sikit. Okay, now I can see the bottom. My apologies about that. Okay, so you can see here, beautiful result. So they give a very nice beautiful result. So they explain to you, the first top row is the count, the second row is the expected values, the third row value is the third row is the row percent. Okay, so where it comes from, all these command, it came from here. You look here, we are doing a cross tabulation between OS gender against OS obesity against we want decimal point up to 2, maximum width is 5, we want expected value, we want the proportionate for row, okay, column no need, okay, then we want the okay, then we want to have the chi-square value in what format? Format expresses. If we do the same command, if I do the same command like this, okay, I change the gender to become gender 2, I will get the answer like this, male and female. So we got male and female. So as mentioned just now, for the top row we have the count, expected values 35.42%. Okay. Okay. Jadi nampak jelas jawapannya. Kita ada minimum expected frequency of 70.76, so we are okay. Do we have any expected value of less than 5? No, we do not have any expected value of less than 5. So our chi-square is valid. However, our chi-square indicated that the p-value is larger than 0.05. It is 0.75. Okay. Okay, what is the weird thing? Okay. They also give you the Pearson chi-square test with Yates correction. Okay. Automatically given. Why? Because this is a 2 by 2 table. Okay, so you end up with the answer for both Pearson chi-square and Pearson chi-square with Yates. Alright, so that is the explanation about the chi-square. Okay, I'm going to stop sharing the screen. Any problem with the chi-square? Okay, ada activity. Advanced set. Sharifah reply. Alah, tak nampak. Prof dah share screen. Okay. Tak apa Sharifah. Wani, you log in, log out. Dapat. Ya. Okay, thank you. Sebab it is satu kelemahan bila dia sharekan pada 9 screen ni, dia ada some bugs yang menyebabkan masalah yang timbul. Same thing happened to me yesterday. I lagi best. I drop je my screen speed, I terus kena kick out. Okay, if you got any problem of lag, cakap, nanti saya akan tukar pada wayar internet. Okay, next. That is chi-square. Any problem with chi-square? Next week, Khamis akan ada soalan chi-square, okay? So, you all kena bagi jawapan dia. Okay. Penat tak buat soalan tu sebab saya kena test balik. Takut jawapan R ni beza dengan jawapan pakai software lain. So, saya kena compare dengan Stata, saya kena compare dengan SPSS. Basically, it is the same lah. Basically, it is the same. Okay, so that is the answer for chi-square. So, you can see the answer. Okay. Ayub stated, please take note for percentages you should have 1 decimal point. For the value of the test statistic should be 2. For p-value should be 3. Okay. So percentage 1 decimal point. For the chi-square is 2 decimal point. For the p-value is 3 decimal point. Before this, it was not a big issue, but now Epic unit insists on that. So if you present your data, please take note of that. The Epic unit insists on percentages 1%, percentages 1 decimal point, chi-square or t-test 2 decimal point, p-value 3 decimal point. Okay, this is expected count. I think I already discussed with you all at length the expected count. If there is no difference, between the case and the control, between the exposed and non-exposed, the row percent is the same. So for the row percent to be the same, that is the expected value. So if you do 17.76 divided by 48 and 19.24 divided by 52, they end up with the same percentages. And the percentage is 37%. Okay. So we already explained about that when you were in semester 1, when you were doing the chi-square lecture. So just in case you all don't believe me, okay, so we just do a quick one. Kejap kasih kecil. Alright, so you can see here 17 divided by 48, you end up with 17.76. 17.76 divided by 48, you dapat 37%. 19.24 divide by 52, you get 37%. So expected value is the value if there is no difference of the rate of the disease between the case and the control, between the exposed and the not exposed. That is the explanation about the expected count. Okay. So if there is, that is the count expected if the null hypothesis is true. All right. Okay, next one. To see whether okay, I'm not going to cover this one. This one is same like chi-square. Okay. Okay, let's not worry about this. Okay. Okay, this one is the chi-square if the chi-square is not valid. Okay, example, you got STC, you got 4, 1, 2, 3, 4. Our problem is race number 4, others, there's only one of them. Therefore, if you have only one of them, when you run the analysis, you get expected value of less than 5 in that cell. Okay, so you got 2 out of 8 When 2 out of 8, then that is already 25%. So 25%, your chi-square is not valid. And also the smallest value of the expected count is 0.37. 0.37 is below than 1. Like Ayub says, below than 2. Okay. Okay, we run the analysis. Okay. Okay, for ethnicity and obesity, we have a problem. Why? There are 4 groups ethnicity. You run like this. Oops. Oh, koma terlampau jauh. Okay. Koma terlampau jauh. In chi-square test, cross step, chi-square test. Supposed to be true. True. T in chi-square test, T. So okay, chi-square test T. Oh, sorry. Dia cuma katakan chi-square tak valid. My apologies. So they are saying that here the chi-square test is not valid. Why it is not valid? Because there are cells with expected count less than 5. So 4 out of 8 have expected count less than 5. Therefore, the chi-square is not valid. Okay. So this one nothing to do with the command. Command is okay. So you can see here we got 4 cells. Okay. Expected count less than 5. So 1, 2, 3, 4. There are 4 cells with expected count less than 5. So we have problem with this chi-square. Chi-square tak valid. So since chi-square tak valid, what are we supposed to do? We are supposed to merge the cells. So we have to merge the cells. We have to recode the data to come up with a new variable, ethnic 2. So ethnic 2, you have to record the value Malay equivalent to 1, the rest equivalent as K. So this one is where the problem arises. How do you recode? I'm not sure whether you still got the data or not. Okay. So you can see here, we have gender 2. Now we have to recode to create ethnicity 2. Okay. So ethnicity 2, okay, let's open up the command for recode kepada ethnicity. I don't know whether I still got it or not. Ethnicity ke dah buang? Let's see whether dah buang. Okay, sudah buang. Okay, so which one of this command? Let's have a look. File, open file, script 1. Nope, not this one. File, open file, script 2. This one for gender. File, open file, script 3. Script 3. So it means we have to type in the command for record. Never mind, it is good practice. Okay. So let's look at the command for record. Okay. This is the command for record. Okay. So we are going to record the ethnic to become ethnic. Okay. So how are we going to do this? Okay. So what is important is just this one. Yeah, man. We just do everything. Okay. Control C. Okay. Let's go and enter the command inside R. Okay. New file R script. Paste. Okay. So we're not going to attach OS2, we're going to attach OS1. Okay, so why? Because the data we use is OS1. So we're going to create new variable OS1 ethnic 2. Okay. So OS1 ethnic 2, we're going to record from ethnic 1 equivalent to 1, ethnic 2 equivalent to 2. Oops. Sorry. Backspace. Backspace. So what happens inside here, we are recording all this data. Okay. So we don't care about this. We're not going to get that one. Okay, this one we are going to relabel. We are going to relabel into Malay and others. Okay, this one we don't need. Okay. Okay, please take note we are doing data OS. Okay, so this is the command. So I'm going to save this one. So record R. Record ethnic. Save. Okay. Now I'm going to run all this command. Run. Oops. Okay, sorry. Run. Okay. So we already created a new variable. The new variable is OS. So you can see we've got 21 variables here. So the new variable that we created is ethnic 2, Malay and others. Okay. So we're going to save the data set. Okay, save project, save project. Never mind. Okay. Okay, so we already saved. We already have the dataset, the necessary dataset for the ethnic duo. Now we're going to run the command for after we have already recorded. So you can see here. Now we are going to run the command again. Okay. But we have merged the cells for the ethnicity from 4 to become only 2. From 4 to become only 2. So when we type the command in, paste. Okay, so you can see here. So cross table, OS ethnic duo against OS obesity. Okay. So here is the risk factor, here is the outcome. The digits 2 decimal. Maximum width is 5. You want the expected value. You want the row percent. You don't want the column percent. Okay. You don't want the true proportion. Okay. So you want, what do you want? You want the chi-square value. Okay. So chi-square value you want. Then in what format? SPSS. Press enter. So now you can see here, instead of having 2 by 4, sorry, 4 by 2, now it is the table is 2 by 2, Malay and others. There is no problem of expected value less than 5. So you can see here, there is no expected value less than 5. There is no expected value of less than 1. And the chi-square is valid, although it is still not significant. So p-value is 0.669. So there's no difference of obesity by the ethnicity. Alright, so that is how we do the okay, sudah 1 jam. Okay, no question, semua tengah terperanjat lagi. Tengah terperanjat dapat soalan exam. Okay, I'm going to go next one. Deng 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 deng. Okay, so next one. Kita dah habis chi-square. Okay, Fisher. Okay, so kita dah sudah ni, dah sudah boleh others. Level education. Level education. Okay. If you do 2 by 2 table, you still got problem. If you do 2 by 2 table, still got problem. Still cannot use chi-square, then you use Fisher as exact test. To use Fisher as exact test, you just change from chi-square to become Fisher. You just change from the chi-square test to become Fisher. Okay. So the command is as above. You just change the chi-square to become Fisher. So how to do that? Just the arrow up. So chi-square become false. And just add Fisher equals to 2. Then you put your comma there. Okay, enter. So automatically you get the Fisher's exact test. Then Fisher's exact test, the p-value is okay 0.745. Okay, sorry. Ooh. Okay. So looking here, okay, this one chi-square, no problem. This one is correction, no problem. This is Fisher. True or solution equal to 1, this is this P. Wow, problem, which one to use? Looks like the top one. Okay, let's look at the notes and see how it is discussed. Okay, so based on this one, we got three possible answers. One is true odds ratio is not equal to 1. For this, you need to do a two-sided test, 0.809. Okay. Alright. So this is how you report if you are using the Fisher's exact test. So using the Fisher's exact test, there is no chi-square value, and there is also no degree of freedom. Alright, and with that we finish the second one, which is the chi-square and Fisher's exact test. Okay, all very quiet. Trauma gila. Alright, so let's not worry about that. Okay, let's finish this one so that we can continue with our daily activities. Remember, this Thursday we're going to do a dry run on the R for the computer based exam. Last. Allah, mana benda ni? Correlation and linear regression. Okay, so what we have done? We have done mean, mode, median. We have done t-test. We have done PET t-test. We have done the non-parametric test. We have done one-way ANOVA. We have done chi-square. We have done Fisher. And last one is a correlation and regression. How many slides we got? 24. Die lah like this. Okay, this one is mentioned about R. Let's not worry about that. We already discovered this. We already covered this previously. Okay. Okay. So as I mentioned before, we are not interested in theory, we're just interested in the R. So we're going to do the R command. Sorry, 1,000 apologies. Forgive this old man. Sebab sekarang ni I bawa banyak buruk ni. Mula si nasi kacau ni. Lepas tu share. Lepas tu dapat mesej ni sekarang tengah ada meeting. Ada dua meeting. Satu meeting webinar, satu lagi meeting pengajaran UKM. Buat bodoh kan. Kita ngajar je. Okay, so here we have a plot. So this plot is for correlation. So we're going to click on the correlation command. So, oops. Okay, so you can see here there's a command. So they ask you what you want. You want to plot between X and Y. So what is X? X is the age, Y is the score before. Okay. Alright, so let's run this one. Okay, immediately you can see here the plot is given here on the right side. Okay. The older you are, the lower is your knowledge before the intervention. Okay, so you can see that. Okay, let's go and settle the next one. So the next one, okay, this one clear. So you can see that already from the plot, you have a linear distribution. So you can use Pearson correlation. So the command is like this. What you want to do, you want to do correlation test. What is the X and the Y? X is age, Y is knowledge pre-intervention. What is the analysis you want to use? You want to use Pearson test. So how to do this? How come she got the question mark? Kesian Hanan. Hanan tak boleh install package. Try removing one Abdul Hanan. Allah. Sorry lah Hanan. Tak apalah. G-Tools. G2 guna untuk apa? Apa? Nanti you fikirkan ya. Ada. Sebab saya punya soalan ni boleh buat tanpa any of the tools. Alright. Paste. You want to do correlation test. Age versus knowledge. What is the method? Pearson. Okay. You already saw the R here is negative. The R here is negative. Why? As the age increases, the Y decreases. True enough, the R is negative 0.71. The R is negative 0.719. Okay, and the p-value is very, very significant. Okay, therefore nothing much we can do about that. Okay, we just report the value of the negative R. Next. So it is significant. Next. Ada apa? Okay. This one theory about y equals a plus bx. Okay, we already discussed this before. Okay. So this one is the command for linear regression, and the command for linear regression is just AB line. So you just type here. Okay, please take note, you can choose your color. Okay, you can even decide on the thickness of the line. Okay, what do you want to draw? You want to draw an AB line. Okay, between what and what? It is linear regression between knowledge and age. So you can see here the line here. Okay, the line is like that. Doctor cannot see the line. You want to change color line, can? Change to color red. Red. So no can see better no. Okay. So you have this AB line drawing for this software. Okay, between knowledge and age. LM linear model. Okay. So how to do simple linear regression? Okay. Our variable here is your interest is about knowledge and age. Okay, you want to do a linear model between knowledge pre and age. Okay, so you have to run the analysis like this. Okay, so you declare you want the knowledge and age equals to the linear model between knowledge all pre and versus OS age. So you click here, type, okay, they run the analysis. So they run this analysis, you end up with this table. Okay, this table got the coefficient, the residual, the effect, the rank. So you end up with one table of all these values. So now you want to see the result of summary. So the summary of knowledge and age. So one of the big difference here, when you run the analysis for linear model, they create a new table. They create a new table. Then from there, you get the summary, and from the summary, you get the value of the linear model. You get the y-intercept, which is 33, and the value is minus 0.5. Y equals A plus BX, so A is 33, minus B is minus 0.57. Okay. Okay, so 33.31841 minus 0.57 H. You end up with the answer of the linear. Okay. Dang, 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 dang. You can set for the 95% confidence interval. Okay. But let's not worry about that. Okay. So this is the confidence interval. One reply dah dapat. Ngada drama lebih. Okay. Okay, confidence interval we end up with the confidence interval. Next one. So based on all the answers, knowledge all is equivalent to 33.318 minus 0.57 each. Why? Because this is what the result you get from the above table. So what is the R square? Okay, R square 0.5172. Kebetulan kebetulan. This is 571. This is 517. These two values are different. One is the value for the regression coefficient. The other one is the value for the coefficient of determination. Okay. So when you draw a table like this, you just show that the value of the B and the confidence interval of the B plus minus 95% CI. Okay, the T is given, the P value and the R value. Okay, and the R square is 0.571. If your aim is to create a model, you just report the model. Knowledge before intervention is 33 minus 0.578. Okay, then we already explained about R square. And with that, we finish the lecture for today. Yeay, sudah habis. Ada apa-apa soalan? Okay. So, tahniah, anda telah tamat sesi belajar art. Kita akan gunakan ini dalam exam. Untuk mengelakkan ada yang menangis, bunuh diri dan sebagainya, hari Khamis ni kita akan demonstrate how to use R dalam a real study. Okay, so jangan panik, jangan ragu, jangan segan. Okay, kita akan buat ini semua pada hari Khamis nanti lagi sekali. Kita akan buat pada hari Khamis. Okay, so Khamis ni kita akan start. Okay, alright. So selamat menjamu selera, selamat membetul kereta, whatever. Thank you. Sedih je Zul. Alright, okay. Okay, yeah. Siapa ni? Dia kata dia Ayub dia 571 dengan 517 dekat-dekat kan? Ya, I share screen. Okay. Sekarang ni saya hanya rely pada result Ayub je. So result Ayub kita run tadi, kita dapat R squared. Okay, dia ada dua R squared. Satu multiple R squared, satu adjusted R squared. Kita sebab ada variable satu je H, kita bukan ada lebih satu variable, maka kita kena pakai yang multiple R square ni, bukan yang adjusted. So yang multiple R square ni 0.5172. Boleh nampak? Okay. Kalau you kebetulan lah beta dia, regression coefficient dia negatif 0.571. So satu tu 571, satu lagi 517. Okay. So R square dia memang 0.517. So 52% of the model can be explained for by the variability of the knowledge can be explained for by age. Lagi tua lagi bodoh. So lagi muda lagi pandai. Alright. Okey, kita tengok Tengok. 41. Tu, alright. 5172. Oh, yang bawah ni. Alright, betul. Dia punya R square salah. R square dia 571 salah. Patutnya 517. Rasanya UKM tu first group kot, dia ajar R kot. So nota ni tak fine tune lagi. Dia lagi banyak ajar, lagi banyak kita kesan kesilapan dia. So sebenarnya keputusan yang kami buat semalam semasa bengkel e-learning ni, yang terbaik sebenarnya bukan pensyarah mengajar. Yang terbaik adalah kena student mengajar. So patutnya Ehsan, Hanan, Zawani kena take turns mengajar topik-topik ni. Itu yang cara terbaik. Bila you all kena mengajar, itu adalah ilmu yang paling tinggi. Bila saya kata you all ni group PhD, saya ngajar, dia orang tanya balik, group PhD patut dia yang ngajar. Alright, tak apalah. Dah habis pun. Exam je. Alright. Okay, saya stop recording. Okay, oops, dah stop lah. Okay, saya hang up Okay, bye.